Hello guys, welcome back to my class number 3 on topic of integration. In this class number 3, I will teach a subtopic concerning integration of polynomial functions by substitution method. My name is Engineer Goodluck, and you can contact me through my email goodluck.daudk@gmail.com, and I'm from Tanzania. Generally, integral of the form f of x is equal to integral f dash of x dx, such that f dash of x holds the following properties of the product of two functions, such that one function, that is g dash of x, is a derivative of another function, which is g of x. When we are in this situation, we solve this kind of an integration through letting g of x equal to any variable. Not g dash of x, we let g of x is equal to any variable, and the rest of method we will see in examples. As well, f of x may be equal to f dash of x dx, such that f dash of x holds the following properties: is a quotient of two functions, such that one function g dash of x is a first derivative of other function, which is g of x. In this kind of expression also, so we let g of x is equal to any variable. So, to understand more on this technique, let's consider the following example. From example, we want to obtain f of x from f dash of x, given that f dash of x is equal to x raised to 4 times z x raised to 5 plus 9 power 7. When we look at this expression, we see this is g of x and this is g dash of x, and the 2 is f of x is equal to x over under root of x squared plus 3. When we look closely, we see this is g of x, and this expression inside the under root is g of x, and this is g dash of x, g dash of x, and this is g of x, which means we obtain x after differentiating x squared plus 3, and there we obtain x raised to 4 after differentiating x raised to 5 plus 9. Don't consider 7. Okay, let's see closely. We know in order to get f of x, we must integrate f dash of x with respect to the x. Okay, from example number 1, f of x is equal to f dash of x, which f dash of x is equal to this function, and this function obey properties of the expression, which is there are two functions, x raised to 4 and x raised to 5 plus 9 raised to 7, and when I differentiate x raised to 5 plus 9, I get x raised to 4. So this is g dash of x, and this function x raised to 5 plus 9 is g of x. So this is g dash of x, and this is g of x. So we let u is equal to g of x, which is x raised to 5 plus 9. So when we find du dx from this expression, we get 5 at this position and we get 5x raised to 4. So when we get back here, where u represent this, so here we have u raised to 7. So integral of u raised to 7 du x raised to 4 dx represent du over 5. So we have du divided by 5 is equal to 1 over 5. We get out of an integral sign. Integral of u raised to 7 du is equal to 1 over 5 u raised to 7 plus 1 divided by 7 plus 1 plus constant c. We get u raised to 8 divided by 40. 5 times 80 plus c. But u is equal to x raised to 5 plus 9. So we substitute back. We get x raised to 5 plus 9 brackets power 8 divided by 40 plus constant. Let's look on example number 2. F of x is equal to integral of x divided by under root of x squared plus 3 times derivative of x. This is g dash of x, and this expression inside the under root is g of x. This is g of x, and this is g dash of x. So we let gu is equal to g of x, which is x squared plus 3 plus 3. When we differentiate du with respect to x, we get du dx is equal to 2x. So u is equal to x squared plus 3. So where x squared plus 3 place u at this position. When u get at the top, we have u power negative half. So is equal to integral of u power negative half. And x dx is equal to du divided by 2. Is equal to du divided by 2. We get a half outside the integral sign. Integral of u negative a half du is equal to a half times integral of u negative a half plus 1 divided by negative a half plus 1 plus constant c. Half and a half cancel, we remain with under root of u plus constant, but u is equal to x squared plus 3. When you substitute back, we get under root of x squared plus 3 plus constant. Okay, thank you. I will see you in class number